Hey YouTube, JP Dillon. Welcome to part 2 of the 79 GE Portable. Right now I've got a subber tuner hooked up to the IF strip and there is no change, so we can eliminate the tuner as a possibility for this failure. And I know it's kind of cockamamie, but I've got my little subber tuner. I've got it on a TV on an isolation transformer, and changing things on there doesn't do anything for the picture. It's still just a nice white raster. So we need to pull the board again, and we need to look in the IF strip for things that are obvious. And if I'm really lucky, there'll be the service literature in the back of the TV. Inside the back cover you'll see 2 screws, and after you remove them you'll be lucky enough to see this. And this was service literature that General Electric included with some of its models. If your serviceman was nice, he put it back into the little container, and if not, then, well, it went missing. Let's see if I can get it unfolded here so we can take a look at it. So as you can see, it's pretty expansive. It's a total fold out. On one side it gives all the board layouts and all the part numbers. It's pretty handy to have this. It tells you how to converge the set. So this is nice, and it tells you a little bit about how the power supply works, all the regulated voltages you should get. And up here we were getting that 22 volts on our tuner, and we've got the 145, which is like 151. 155 is about 155. We've got the 12 volts on the IF, 20 on the audio, 21, all that stuff is there. So it's really specific. And if you flip this over, then you see that we have the entire schematic diagram, which is nice. And although I hate having something this large and cumbersome, this is great because it's like tells you all the waveforms, what all the voltages are supposed to be, and all that. So this will be useful in troubleshooting this problem. And obviously, since we subbed out the tuner and it's not changing anything, the next step is the IF strip. And it looks like they're just using an integrated circuit for the IF. And you've got all these tuned coils and everything, and then that comes out. There's a loop that goes back through your AGC, and then it gets sent to the audio, and then it gets sent to the video and the color processing. Chroma's over here. So yeah, and then that color monitor, not in all sets. I don't know if that's a VIR thing or what. I don't know if it is or not. I think that was later. Anyway, so there you go. Nice vat of service literature that will help us in figuring out what's wrong with this, hopefully. But I think the next step is to pull the board again, open the IF can, and look for anything obvious. Alright, so here's where we're at so far. I've removed the bottom shield, and there are a couple of ground connections on the cans that need to be resoldered, but I'm pretty sure that wouldn't just absolutely kill all IF activity. I've checked all the little feed resistors. In the set I get 12 volts supplied to the chip, but the nominally the chip voltages are kind of weird, indicating that that might be defective. But I can't find a cross-reference for this. It listed as IC 120, and it's a General Electric 1571, which I don't have my semiconductor book from them handy, so I don't know what this is, and I think my book might be older than this set, so I'm not sure. So I need to do a little more digging and figure out what this IC is, and see if I can find just a replacement for it. Very likely that will cure our ailments, because I'm getting a lot of erroneous voltages on the feedback for the AGC and the IF. That voltages which should be there aren't, and voltages which shouldn't be there are. So it kind of makes me wonder about that. But anyway, so that's where we're at with this board. And I'm going to try to find a replacement chip for this and then pop it in here and see if that makes any improvement. But for now, that's where we're stuck. Alright, so this is what having an old set of books is about. This is the 16th edition ECG replacement guide. And that never cross-references to an, what is it? An EP84X34, which when you look that up, brings you to an ECG 1545. And if we look at that, that looks like our guy, our 16-pin DIN. And that's that guy right there. And if we take a look at that, let's see, 1545, there we go. So 1 and 2 and 15 and 16 are the input pins, which seems to come from the tanks in there. So I think that's our guy. I've been getting these from Vetco Electronics, so I gave them a call and they do have it. So I'm going to go ahead and order this chip, and when it arrives we'll pop it in and see what happens. Alright, so fast forward a little bit. I got a IC in the mail. It's the NT1545, and it looks like it's the correct physical replacement at least. So really it's just a matter of getting it out of its little protective area and getting it into the socket. Whoop. I know this is not electrostatic approved methods, but yeah, I'm really more concerned with just getting this in here. Do a little bit of pin bending. Let's make sure all the pins are seated right. Looks like they are. Put that guy down in there. This is our main IF amplifier, and even with my subber tuner, I still wasn't getting any picture or sound, so maybe that will fix that problem. We'll see. Here's hoping. Alright, so I've got this kind of loosely reassembled here, just enough to run it. There are no shields on the IF top or bottom. I've just got it slid in here kind of haphazardly so that we can see if it runs or not. And we should be able to get snow of some kind. Really don't know what's going to happen at this point, but we'll find out. Yeah, it doesn't seem like there's any change. Still got a raster. Raster, no sound. But I've got tuner crash. So that would tend to suggest something's going on. Let's hook up the signal generator again just for kicks. So even with the signal generator hooked up, we still don't have much of anything. That's kind of new though, that rolling mass there. It's like it's trying to come in, but it's not really. Didn't have that before. And there was this one control in the back here. It says horizontal hold, but when I adjust it, watch, you get brighter and darker. But the horizontal never locks in. That's a clue there. We can see that we're overlapping in frequencies and stuff like that, but it never locks in. Very interesting. And it's rolling sideways too, almost like we don't have any sync whatsoever. Although, if I change the switches on the pattern generator, I can in fact get some semblance of a picture, although it's rolling and moving and doing pretty much whatever it wants. So I've got weak, no signal, no sync, nothing. So let's take a look at the schematic. So here's our IF section, and here's the chip that we just replaced. So I need to check some voltages there again. It was very wrong on the other one. The chip was kind of warm, so I thought that maybe that was an issue there. And I have no sync, so we have to come and take a look at where the sync separation takes off. And this is why I don't like giant schematics, is because it's just kind of tricky. Chroma circuits, don't really need that. That's a little bit too far down the line. So that comes down from our IF output, and then goes to our sound, which is over here, or that's our sound output, looks like, or maybe not. What is that? Oh, that's our first video amp. So we need to check there too, make sure there's 12 volts there, and make sure Q200 is working, because without that we wouldn't have our raster. But it's weird that we don't have sound either. I don't have any audio other than just a hiss. And trying to see where the audio section comes into play. This one's kind of a puzzler. I'll take some voltage measurements here. I also just noticed that the sound takeoff point, if we follow it down here, this detector coil actually is fed from the video here. And so if this is, yeah, because you have a trap here, that's supposed to take the sound out of the video, or at least that beat pattern. Maybe I'm just not following this. No, sound takeoff comes from up here, off of the pin of the IC, pin 12, looks like. So, I don't know, we need to check the IC voltages again and take a look at that video amplifier. The fact that I don't have any horizontal sync or anything like that is probably due to a lack of signal, not in the horizontal section. So I'm going to take a look at that, and then we'll compare things. Okay, so what I notice here are two very wrong voltages. Number one is pin 3, which I have 6 volts on, not 0.7, 6. Now that could be because there's no signal there and it's jacking up that voltage. But then I have at pin 9, or pin 14, or let's see, what am I looking at here? Yeah, pin 14 is supposed to be 9 volts. I've got 3.6 there. That's going to piss it off. That means it's not going to run very well. So we need to trace back here and find what it looks like on R141, which is the 1.5K, and then there's a test point there, TP1, which comes in from Y160. Now the question is where does Y160 come from? Looking at our power supply here, Y160. They don't mark anything here, they just call it sources. I'm not really sure what's going on about that, where Y160 goes. Well, anyway, we can take a look here at R141, which should be a 1.5K. And obviously we're going to have 3.6 on the low side. Now alternatively here, C138 could be leaky, which would pull that to ground for sure. It's very unlikely, but not impossible. Let's see if we can find out where R141 is on this board. There's R140 down there, and the depths there, can't really see it because it keeps wanting to focus on the wire. R140's there. Maybe that's it there. 1.5K. Well, anyway, this is in the way, so let me poke around and see if I can discover anything useful. Okay, so after tracing this out, it's true that I have 3.6 volts on either side of this and all the way at test point 1. And this goes to Y160, which is supposed to be some kind of regulator diode, like a Zener diode that's supposed to keep the voltage at a certain point. Now I found Y160, which is down there. You can see it there, Y160 there inside of that can. It's a little bit tricky to get to from where I'm standing. I can pull this out a little bit and maybe get alongside of it. But there's 4 volts on one side and 3.5 volts on the other. So I don't know if that's a Zener or what. I'm trying to find it on the schematic here. It looks like it's supposed to be somewhere in the IF stage. Here's Y142. Trying to find out where the hell it is. Oh, there's Y160. It's not a Zener, it's just a diode. And it was weird because it's looking like here. Okay, this is capacitively decoupled. I was wondering why I was getting the 6 volts here. Where does the 6 volts get supplied from here? That's test point 2, the RF AGC control. I'm not going to look at this so much just yet because, well, it's probably cranking this voltage up because there's no signal there. But this low voltage here might be the reason why we don't have any IF activity. So I need to find out why that's coming there, because from the back of this we have 3.5 here, which tells me that we should still have more voltage over here, because this is only 0.6 drop. I mean, this is just a standard switching diode, 0.6 drop. We have 3.5 here, and over here we have like 4 something. It's not that big of a difference. Let's take a measurement here again. Yeah, we have 4 on the anode side and 3.5 on the cathode side, so we're just looking at the voltage drop across this. So back here the voltage is low too. In order to get 9 volts at our test point, we would need 9.6. And it says here that we have 6 volts here as a supply line that feeds this. So where do the extra additional 3 volts come from? So that's a little weird. You've got another AGC supply line here that goes up and around, and that comes, oh, that's the capacitively decoupled to ground. That goes to pin 11, but I have 12 volts here. So there's 12 volts on the top of here, and there's 6 volts here through this divider network. So there should be like 6 volts here, or actually there should be about 9 volts here between the 12 and the 6 in the divider. Yeah, so we need to check R162 for increased value, R160 for increased value, and then the thing to do would be to see if we have our 6 volts here and see if we have our 12 volts at the top of 160. Blah 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 blah, troubleshooting blah blah blah. So this is not the easiest one to work on. Everything's kind of crammed in here. I don't really like it, but let me do some homework and see if I can figure this one out. Alright, so after poking around, here's what I know so far. At the top of R160, I do have my 12.6. I do have 6.2 here. I've got about 4 here and 3.5 here. Now, one other important thing that I just noticed here is the pin next to it, which is the AGC line here, has almost no voltage. There's 1.9 volts here. There's supposed to be 9 volts. Now, tracing this back all the way to pin 8 here on the connector, I've got only 2 volts there, which goes back to our theory about the tuner again. Now, when I hit the lockout, meaning between wafers, this transistor does clamp, and so that voltage goes from being 2 volts to 0 between channels. But 2 volts really isn't enough to turn that on either. Now, as you can see, all that transistor does is appear to just clamp that voltage between channels. It could be leaky, and that could be pulling it down, but that's kind of unlikely. What we really have to do is figure out where that voltage, that AGC voltage, is sourced from. Looking at R154 there, that's a 10K. And that comes from that 12 volt source, so that could be open. And then you've got this RF AGC adjustment, but turning that doesn't change the voltage at all, so I don't think that's it either. So let's look at R154 and see what the voltage is we get on that, because we should have about, I don't know, 12.6 on one side, and according to this about 9 on the other. So let's see if I can locate that guy, 154. He's probably buried back in here. Yeah, that's one thing I don't like about this, is it's just hard to find. It's 147, and then we jump to the 500s, so that's the wrong section. There's the 200s, R206, 22222. You can't really see anything. There's 58. What did I say it is? 54, 154. And I'm trying to look down in here to see if I can see it kicking around anywhere. 127. Alright, well, I need to find that, and then we'll take some voltage measurements to see if we're getting the 9 volts we're supposed to. Alright, so checking this point here, top of 154 I have 12 volts. Bottom of 154 I've got about 2.2 volts. So things come to mind. Number one, this resistor could have gone way up in value, which you really don't know until you pull it out of circuit. Also, this line has this 1000 microfarad capacitor decoupling to ground, and this could be defective. Now, it could be defective in one of two ways. It could be defective in the sense that it's leaky and it's pulling the voltage down, or it could not have the capacitance anymore and it's not charging up, because you got to remember that this 12 volts is going through a 10K resistor, and it's having to charge this capacitor. So unless this capacitor is in top shape, it isn't going to work so well. So we need to take a look at C125, and we need to measure this and make sure that it's still 10K, this 154 here, and maybe that'll bring our voltage back up. Where is, see, that's the other thing, is that we have to find, what does it say here? That's C124. It's kicking around here somewhere. And it's going to be 1000 microfarad, so it is going to kind of stand up a little bit. There's 123, which doesn't look like a 1000 microfarad. What are you? So we need to search for this, because it doesn't look like it's inside of here. Maybe it's off the board somewhere. Yeah, I don't know. Again, got to search for it. And then when I'll find it, we'll desolder it, pull it out, and test it. Just make a correction here. That's a 1,000 picofarads. That's a 0.001 microfarad, not a 1,000 microfarads. That would be crazy. And they've got the annotation for microfarads here, so this is probably a 0.001 or 1,000 picofarad, whatever it is. So we have to test those two components because the voltage here is way low, and it's supposed to be 9 volts at the bottom side of that 270 ohm resistor, and I've only got 2.2 volts here, so this is suspect. I don't think there's anything else in this circuit. It's a 4.7K line to that clamper transistor there. That was the same voltage on the downside of that too. There's no voltage drop across this really, so there's not much current flow. Anyway, more interesting stuff. Alright, so I'm kind of stumped on this one. I do have my 12 volts here. I've only got 2 volts here. This 10K is 10K out of circuit. And this capacitor removed from the circuit does not raise this voltage up at all. This 270 ohm is still alive. So I'm not sure what to think about that. Maybe this is just not conducting correctly because lack of information. I don't know if I mentioned before, but that video section is working fine there. The low voltage points here are pin 3. Well, actually the wrong voltage point's pin 3. Pin 3, which is supposed to be 0.7 volts, is 6 volts. Pin 4, which is supposed to be 9 volts, is a little hair shy of 2 volts there. It's like 1.89 or 1.92 or something like that. Doesn't vary much. And then this one up here, pin 14, which is supposed to be 9 volts, is measuring 3.6. And so far, everything seems to check out except for that low voltage here. You've got low voltage here. This is 6, but this is like 4. I don't know whether this is how this gets so high. That's what I wonder. Not sure where they could have got it. And how was I measuring 6 volts there when there was only, or maybe that was the low side. I can't remember what I was doing here. Let's take a quick measurement on pin 3 again just to refresh my memory. Just a little chip down there. Yeah, 6.7 volts there when they're supposed to be 0.7. So not sure what's going on with this guy. We turn our little signal generator on here. I get a very weak signal, no sync, hardly any video at all. Now, I tried subbing it with a subber tuner. That didn't seem to change anything. And these AGC voltages are all wrong. So I don't know if that's a defect of the tuner. I am getting, you can see crashes of static on the screen here as we go between channels. But something ain't right. The AGC voltages are all wrong. I can't really figure out right now what's causing it. It's kind of beyond me. So we're stuck on this one. If anybody's got any suggestions, they're more than welcome to pipe in. And I'm about ready to pitch this thing. It's getting on my nerves, and there ain't no way it's worth it to me other than for maybe entertainment value. So I'll keep at it a little bit longer, but for right now, maybe I'll work on something else. These IC based sets have been giving me a run for my money so far. So that's where we're at. We've got an improvement in the sense that we have a weak rolling picture with no sync and no sound still, whereas before we just had straight up raster. And although the voltages on the old IC were way wrong, This one still doesn't have any AGC voltage on it. That's correct. So I wonder if that's part of the reason why it's not working. But like here I would get 5.6. Likewise here. This 0.7 was 6 volts, way wrong. The 9 volts was like 1.9, way wrong. This was like 7.2. This was 4.8. This was 3.8. This was 7.6. They're all really close here. It's just this whole AGC thing here is not working. And for the moment, I can't seem to figure it out. So, until I can, we'll focus on something else, unless somebody else has got some pointers. Thanks for watching the video.